I think we've held off long enough. You two men are here for your check, aren't you? Let's proceed with the presentations. Neil, would you come up? This is the gentleman I got names mixed up on a while ago. We've only known each other for 20 years, I guess. We have several presentations to actually make here. Richard Alley, will you come up to the stage, please? You'll make the introduction. Right.
Richard, I'm going to make an introduction even though you're up here, and what my paper said is I'm going to ask you to join me on the stage. So you can stand while I say wonderful things about you. Like our dean, I wanted to introduce myself. My name is Neil Sullivan, and I'm standing before you this evening as a member of the executive committee of the John and Alice Tyler Prize for Environmental Achievement. Now, as you all know, there is a certain guilt by association that perhaps a touch of fame could also rub off in that association, and hope does spring eternal. So tonight I'm going to test this idea. Now, I am personally celebrating this evening, and that is the fact that I'm a graduate of the Pennsylvania State University twice. Go Nittany Lions. And the University of California at San Diego, Scripps Institution of Oceanography. And I've been a professor at the University of Southern California for 36 years, where the Tyler Prize is administered. And I'm a former director of the Office of Polar Programs at the National Science Foundation, and director of the United States Antarctic Program that funds research in the Arctic and all research in the Antarctic. So you're starting to get the picture about this rubbing off of some common backgrounds. But in truth, that's all about me. Somebody recently said that. And I want to tell you most about somebody else, and that somebody else is Professor Richard B. Alley, because it's Richard who's being honored here tonight for as the first of two outstanding individuals, as you've heard, for our 2009 Tyler Laureate. Richard is a graduate of Ohio State University and the University of Wisconsin-Madison, and he worked at the Geophysical and Polar Research Institute in his student days, and just right after graduating at the Polar Research Center. He began his career as a professor at the Penn State University, Pennsylvania State University, in the Department of Geosciences, where he teaches hundreds, almost thousands of undergraduate students. And they love him so much, I think they put him on YouTube. So it tells you something about him. And he teaches some graduate students, and he conducts research on paleoclimatic records as a means of understanding the Earth's climate system and its history, and of projecting future changes in climate and sea level. Now, I have a sort of a news flash for you, and that is Professor Alley, given that background, is considered one of the world's leading climate researchers and glaciologists. But he does not believe in global warming. And quite frankly, neither should you. And the reason is because global climate change and global warming are not about beliefs. Not economic ones, not religious, political, popular, or other beliefs. They're about evidence. The evidence that's painstakingly collected in support of understanding. Another key word that keeps popping up tonight. And it's understanding that our Earth is warming and we humans are contributing substantially to that rate of warming. And Richard Alley has contributed greatly to providing compelling evidence of the warming, and especially to the rapidity to which it's occurred in the past and is likely to occur again, maybe soon in our future, in part, maybe large part, that rate of human activity. And this is why Richard Alley is about to come up and join me, which he did on stage, and receive the Tyler Prize for Environmental Achievement. But I'd like to point out something else. His work, Richard's work, is not armchair science. Nothing against you theorists who work with the material between your ears, called your brain, whether it has a shot of dopamine or not, but it's in that general region. Richard has gone literally to the ends of the earth, repeatedly to the ends of the earth, to interrogate Mother Nature. And he's lost a lot of body heat getting there to get that evidence for all of us. Richard's scientific work comes from the meticulous analysis of ice core data that he had collected during 3 expeditions to the Antarctic continent, to the ice sheets of the Antarctic, to 5 expeditions to the Greenland ice cap, so he is bipolar, and to living almost a year in a deep freezer in Colorado. And hence, if you saw the advertisement, that very attractive mauve-colored, is that hat that keeps that brain warm. And then he synthesized this data through careful thought, computer-based models, and testing hypotheses and testing the models that were constructed to help understand the climate system. That is why, also, he is a Tyler Laureate. Now, I'm supposed to speak briefly, but I want you to pick up this sometime and look at page 6, because it gives you much greater detail of the nitty-gritty real research that Richard brought to light in his career. And I don't have time to go through it, but it's articulated rather well. My last comment is really a beautiful little secret of the Tyler Executive Committee. So if each and every one of you promise not to tell anyone else, I will share this secret with you. It's been out of the bag a bit. The committee is always very, very proud of its laureates, as evidenced by the fact that we annually invite lots of important people, influential people, to join us here in this rather elegant hotel for dinner. We actually are especially proud when a Tyler Laureate go on to their careers to become recognized by others, for instance, as you've heard on the Nobel Prize Committee or the National Academy of Science. And the reason my comments are so short this evening, they may not seem that short, is the fact that Richard and his wife Cindy really must catch a red-eye flight so that tomorrow he can join the freshman class and be inducted into the United States National Academy of Sciences. So I think that's a world record going Tyler Laureate to the Academy. And we congratulate you. And now I'm going to pick up a plaque and
We first have recognition from the City of Los Angeles, from the Mayor of Los Angeles.
Thank you, Antonio Villaraigosa. You're going to hold a lot of things here. Why don't we do a photo op on this one, Richard? The 2009 Tyler Prize for Environmental Achievement presented to Richard B. Alley, the Pennsylvania State University, in recognition of your contributions to understanding the relationships between the cryosphere and global warming, the vulnerability of the Antarctic and Greenland ice sheets, and for the alerting us to the potential for contemporary abrupt climate change and its possible implications and costs to society today, you are awarded this prize. And we're going to give you a medal. Congratulations, Richard. It's a pleasure. I'm also going to ask Richard to make a few comments after he receives a very important
There is one more
check.
item, isn't there?
Yes, there is. The check is not in the mail.
It must be a check for $100,000.
It's right here. Podium is yours.
Oh, my goodness. Thank you, Owen. Thank you, Neil. Neil did such amazing things for the Office of Polar Programs, for the Polar Program in general, and we owe him a whole lot. There's a fascinating theory that's been floating around recently, Richard Wrangham from Harvard, that the last piece of evolution of humanity required burning. If you live on raw meat and sticks and leaves and things, it's a little hard to digest, and you spend a lot of your energy digesting, and you have a really, really long gut, and you may not enjoy it nearly as well as you're enjoying dinner tonight. If you get a fire to cook do some of the digestion for you, you can have a much shorter gut and still enjoy it. You know, you just saute it a little bit in some olive oil, and it's really, really good. And then rather than keeping that long gut alive, you can keep a brain alive. And it is likely, certainly a good hypothesis, that we're human because we learned how to burn. And then we tried to burn all kinds of things. And you know, we have spent a lot of our time burning. I come from Pennsylvania, Penn's Woods. When the native people did burn Pennsylvania, but they were mostly trees. When the Europeans got there, we burned all the trees. We had turned it into Penn's Desert. It was amazing. We used to go out and mine the ocean for whales so that we could burn whales in the evening and see. And Pennsylvania, you know, finally said, you know, whales are expensive. And we drilled the first modern oil well. And right now, I think it is a safe statement that we have trees and we have whales because we're burning dead algae and old trees. And the first people that actually thought about this knew that we would run out of dead algae. We would run out of old trees. We'd run out of coal, oil, and natural gas. And we face learning. And the question is, will we burn and then learn, or will we start learning while we're burning? And those are the end members. And we haven't been working very hard on the learning while we're burning. A lot of what we're doing is, let's just burn it all. And what we know now, with very high scientific confidence, is that if we burn it all before we learn, our grandchildren and their grandchildren and people today will have a much harder life, and they will look at us and say, what was wrong with you people? You got this brain, why weren't you using it? And we know this, and we also know that we can really mess things up, and we know that there are solutions, and we know there are solutions that will work, and that maybe make everybody happier before we're done. And I've played a very small role in learning about this. Ram has played a very large role in this, and many of you in this room have. And so it's just such an honor and a privilege to be here to represent a community that has done this work. I'd like to recognize a few people in particular. Ian Mullins, David Elliott at Ohio State, the professors at Ohio State. In Charlie Bentley's group at Wisconsin, I worked with Don Blankenship. My early papers that had impact were leaning on Don all the way through. It was wonderful. Kurt Cuffey was the first student that found me when I got to Penn State, and I have relied on him greatly ever since. Joan Fitzpatrick in the back there found me when we started in Greenland on the ice course and has been a colleague since. And that first year, Eric Saltzman, who's here someplace, there's Eric, was working with him. Peter Fawcett bailed me out in advising a student and understanding the younger Dryas. Todd DuPont is over here, was one of my early PhD students and is doing such good work and still collaborating with us. We have here Eric Rignot and Isabel Velicania, who are great remote sensors of the modern world. Hermann Engelhardt, who's done so much work on the ice sheets, is here. This is a community, and it's a community that's done wonderful work, and it tells us things that we really need to know. I'd also really like to thank my parents, like John Alley and Ruth Alley, who's still with us, my brother and sister. My daughters are inspirations. We will see them tomorrow at the National Academy, and especially to my dear wife, Cindy. Thank you so much.